Hi everyone. Let's figure out the simple steps in which we can draw Lewis diagram. So uh, so let's figure out the steps to draw Lewis dot structure. So I'll explain in very simple 5 steps, and you will be able to draw it then. I'll also take a example to explain these 5 steps. So let's take a very simple molecule, water, and draw its Lewis structure. So इसमें first step would be, which I have explained in previous video also, to calculate the total number of valence electrons. So first is to calculate total number of valence electrons, of all combining atoms. So if we see here in H2O, for hydrogen there is 1 each, and oxygen there is 6. So it's total to 8 valence electron. Total number of valence electrons is 8. Now next step would be to choose the central atom. So central atom, there are some generic rules available. First, choose the atom which needs more number of electrons or bonds to form to complete its octet. So here, and other guideline could be choose less electronegative atom. So in this case, clearly we will go with the first guideline, and we here oxygen needs 2 electrons to complete its octet, and hydrogen needs only 1. So here we will keep oxygen as a central atom and hydrogen as a terminal atom. Now third step would be to draw a single bond between terminal atom and peripheral atoms, terminal atom and central atom. All right, so we will draw a single bond here. Now fourth step is to put remaining valence electrons in form of lone pairs on the contributing combining atom or contributing atoms. So in this case, if we see, there were total there are, so if we see in total, we calculated there are 8 electrons here. H2 has 8 valence electrons. In total there were 8 valence electrons, and And in if we see there are two bond pairs, so four electrons have be already are all two four electrons are already consumed in form of bond pair. So remaining number of electrons would be 4. So 4 electrons we can put as lone pair. Now always remember that that high we cannot never give more than 2 electrons to hydrogen and more than 8 electrons to any other atom. So if we see in the structure, hydrogen is already having 2 electrons. These 2 electrons are shared, so all hydrogen or duplet, because hydrogen makes its duplet. So it's already complete. So we will place remaining 4 electrons as the lone pairs on oxygen. And now fifth step is to check if octet or duplet of hydrogen, in case of hydrogen, and octet of all atoms is complete. In this case it is already complete. So if we see here 2, 4, 6, 8. So oxygen has 8 electrons in its valence shell. Hydrogen has 2, so its octet is complete. So its final Lewis structure would be this. Now let's discuss some more examples. Let's take few more examples here. Let's talk about oxygen. Same steps we will follow. First step, calculate valence electrons. So valence electrons here would be, one oxygen has 6, so 2 oxygen will have 12 electrons. Now step 2, identify the central atom. Here only two atoms are there, so no central atom here. So we will write like this. Both are identical atoms, so we will write like this. Third step would be draw a single bond. Between atoms. So let's draw a single bond here. Fourth step would be to put remaining valence electrons as lone pair. So here 2 electrons are part of bond pair, and if we see there are 12. So 12 minus 2, so 10. So basically we can have 5 lone pairs. So let's put it oxygen. Let's put 5 lone pair. 1 lone pair, 2, 3, 4 and 5. Now let's see fifth step. In this we have to see if octet of all the atoms is complete. If we see here, its octet is complete. 2, 3 lone pair plus 1 bond pair. So it has all 8 electrons. Octet is complete. But if we see here, only 1 bond pair and 2 lone pair. So it has only 6 electrons in its valence shell. Now extension of fifth rule, if octet is not complete, octet of some atom is not complete, convert lone pair to bond pair, lone pair to bond pair to complete the octet. So in this case, oxygen, this is the structure. So it will convert one lone pair to double bond to complete the octet of another oxygen also. So now it has 2 bond pair, 2 lone pair, 8 electrons in total, and here also 8 electrons in valence cell. So this is the final Lewis structure of oxygen, where octet of both the electrons is complete. Now let's take one more example of nitrogen. Same steps we will follow. First, number of valence electrons. Here would be 5 plus 5, 10 electrons. Step 2, no central atom here also. Step 3, single bond. Draw single bond between atoms. So nitrogen. Fourth step, put remaining valence electrons as lone pair. So here 10 electrons were there, 2 electron in bonding has already been consumed, so 8 electrons are remaining. So now we can put these 8 electrons as lone pair. Now if we see, fifth is check if the octet is complete. If we see its octet is complete, already 8 electrons, but if we see here only 4 electrons are there. So to complete the octet, of other nitrogen, 2 lone pairs would be used to would be converted to bond pair. So now nitrogen, and now both have octet complete, octet electrons, and this is the final structure. So nitrogen, triple bond nitrogen, and this is the final Lewis structure of the nitrogen. So this is a simple 5-step method we can follow to draw any Lewis structure. I can give some more examples here, and we can see one more example, maybe CO2. It would be good if we can see CO2 here, where central atom. I would like to give one more example where we can see central atom also. So in first step, let's calculate valence electrons. 4 of carbon and 6 into 2 of oxygen. So total 16 electrons. Step number 2, central atom would be carbon here, as it has only 4 electron, it needs more number of bonds here, and also it's less electronegative, so carbon would be central atom here. So carbon is identified as a central atom. Third step, draw single bond from central atom to terminal atoms. Now since it's carbon dioxide, let's draw this. Fourth step, put remaining electrons as a lone pair. So remaining electrons would be 16 minus 4, 2 here, 2 here are already used, so 12 electrons. As these 12 electrons we can put as lone pairs. Fifth step. Okay, no, let's put lone pair first. So six lone pairs. So now fifth step. Let's check the octet. Complete octet checked. Here octet checked, but here it's octet is incomplete. Octet incomplete. So some lone pair would be, so it still needs 4 electron. So both sides, so 2 more lone pair will be converted to bond pair. Converted to bond pair. So in this case, oxygen, one from here and one from here we can symmetrically draw. And now if we see, octet is complete for all 3 atoms. So this way, this is the final Lewis structure of carbon dioxide.